Hello guys, today I am discussing about discrete random variables and probability distribution. This discussion about definition of random variables, definition of discrete random variables and definition of continuous random variables, example of random variables, example of discrete random variables and also example of continuous random variables. I would like to also discuss about definition of probability distribution and the definition of the probability histogram and some illustration of probability of histogram. So what is the definition of discrete random variable? To know the discrete random variable, we should know about what is random variable. So a random variable is a quantitative variable whose value depends on a sense. In the next slide, we are going to have example of random variable. Now let's move on discrete random variable. A discrete random variable is a random variable whose possible values can be listed. In particular, a random variable with only a finite number of possible values is a discrete random variable. In the next slide, we are also going to have example of discrete random variables. In addition to discrete random variable, we should know what is continuous random variable. A random variable is called continuous if its possible values contain a whole interval of numbers. In briefly, discrete random variable related just finite number of possible values. On the other hand, continuous random variable related whole interval of numbers. Now we are going to have example of random variable. This is an interesting example. Here is a table. This table is number of siblings of students. There are 40 students altogether. A number of siblings from student to student, it varies, so we can call it is variable. If we pick any students randomly, so then the variable is called, if we pick, then the variable is called random variable. For example, 11 of the 40 students, the percentage is 27.5%, have two siblings. This is called random variable because we pick this 11 of the 40 students randomly, and we can also pick 8 of the 40 students. Those who have one sibling is also random variable because it is picked randomly and its relative frequency is 0.200. In our daily activities, we can find a lot of example of discrete random variables and a lot of examples of a continuous random variables. So first example of discrete random variable is the number of arrivals at an emergency room of a hospital, for example between midnight and the early morning at 6 a.m. Second example is number of kernels of popcorn in a 1 pound container. Third example is number of applicants for a job. And now example of continuous random variables. First example is the weight of a box of a cereal labeled 18 ounces. Second example, the duration of the next outgoing telephone call from a business office. Now let's go to the definition of probability distribution and probability histogram. A probability distribution displays the probabilities associated with all possible outcomes of an event. An example of probability distribution is shown in next slide. Now probability histogram. Probability histogram is a histogram with possible values on x-axis and the values of probabilities on the y-axis. The figure of probability distribution is shown in next slide. Here is example of probability distribution. Here is example of probability histogram. on x-axis the values of siblings, on y-axis the values of probability. Now we are going to move the important fact. This one is called key fact 1. That one is sum of the probabilities of a discrete random variable is 1. For example, if the discrete random variable is x, so the probability of getting x and their summation must be 1. And another important fact is key fact 2. This one is interpretation of probability distribution. And we also know that probability distribution describes the dispersion of the values of random variable. In probability distribution, proportion histogram will approximate the probability histogram. In next slide, we will also see the proportion histogram and the probability histogram. So let's take an example. Let's take an example of 3 tosses of a balanced dime. The table shows that number of heads, frequency, proportion. For example, 136 of 1000 observation resulted in no heads out of 3 tosses, which gives a proportion. This proportion is 0.136. The result is more understandable whenever we compare the proportion histogram to the probability histogram, which is shown in the figure of next slide. The figure A is proportion histogram, figure B is probability histogram. Figure A is based on particular observation, figure B is based on formula. For 1000 observation, the proportion of getting 2 heads out of 3 tosses is very close to probability of getting 2 heads out of 3 tosses of a balanced dime. But if we have more than 1000 observation, for example 2000, 3000, then the proportion of getting 2 heads out of 3 tosses will be similar the probability of getting 2 heads out of 3 tosses of a balanced dime. So this is our discussion today. Thanks everyone.